Introduction to Wireless Sensor Networks Part 1. Wireless sensor networks, as the name suggests, are a class of networks where the nodes are sensor nodes, the nodes which have the capability of sensing the physical phenomena that occur around them. These sensing can be of different types. A particular sensor node might be able to sense temperature, might be able to sense pressure. They can sense if there is any object that is moving around them. Sensors can also sense colors, can sense vibration occurring around, can sense whether there is any sound around the sensors, and so on. Now, the sensor nodes have one of the components as a sensor, and these sensor nodes collectively they form a network which is called the wireless sensor network. So, these wireless sensor networks are very popular currently, and they have gained popularity since over a decade now. Sensor networks are very popular because of diverse types of applications. They can be used for tracking an object in a particular terrain. They can be used for medical purposes, for healthcare, for space applications, for agriculture, and so on and so forth. There are large number of different applications of wireless sensor networks. Wireless sensor networks are key to the formation of Internet of Things, and Internet of Things and wireless sensor networks are very important components for building smart cities, which have become very popular since the last few years in our country as well as abroad. So, we are going to look at some of the technical aspects of building wireless sensor networks. Initially, we will start with the introduction. So, the first two lectures will cover the introduction to wireless sensor networks, and thereafter we will gradually build upon, and we will look at different other advanced concepts, other advanced concepts and techniques that have been designed for use in wireless sensor networks. So, as I told you that a wireless sensor network basically consists of a collection of different sensor nodes, and these sensor nodes are typically, not necessarily, but typically they are densely deployed in an area. So, the sensor nodes they basically communicate with one another. The sensor nodes, first of all, they have the capability of sensing the physical phenomena that are occurring around them. For example, the examples of whatever I told you already, like for instance, if there is a light sensor which is in the sensor node, then the sensors can sense the sensor node can sense light. Similarly, temperature, sound, vibration, and so on. So, like this, actually there are different other types of sensing that can happen, and the different types of sensors that can be embedded in a sensor node. The sensor nodes they can collaborate with one another, and collectively the sensed data that is the sensed data that are obtained from these using these sensor nodes, they are transformed into digital signals to process the physical phenomena that are occurring around the sensors. And due to the fact that the sensor nodes have very short radio transmission range, the intermediate nodes in these networks act as relay nodes. So, what we essentially have is something similar to what we had observed in the case of ad hoc networks, a multi-hop kind of architecture. And so basically what happens is the sensor nodes they sense the physical phenomena, and the sensor nodes have very short transmission range, short communication range, and because of which the data, the sensed data from one node through a multi-hop path, they are sent to the remote destination node, and this remote destination node is termed in the sensor network literature as the sink node. Sometimes people often people prefer to call the sink nodes as the base stations. However, keep in mind that there is distinction between sink node and a base station. A base station may or may not be a sensor node, whereas a sink node necessarily is a sensor node. So essentially, if there is a computer or some kind of a data collecting device which is connected to a sink node, then all the data from that are received at the sink node, they could be stored in that particular computing device. So one question might have already arisen in your mind, that why at all do we need the sensor networks? What is the use of these sensor networks? If it is about sensing, sensors have been there since decades now. So sensors have been there. So what is new in sensor networks then? So the distinction between the standalone or individual sensors and the sensor networks is that whereas an individual sensor can sense the phenomena locally in a standalone fashion, in a sensor network you can deploy multiple such sensors and sensor nodes over a larger area in order to get an idea about what is occurring in that larger area. So basically, to have bigger coverage, bigger sensing coverage over a bigger area, this is why the sensor nodes, the sensor networks become useful, and that can be done. So remote, so if somebody wants to remotely monitor a particular area, so sensor networks become very useful. They come out to be very handy, remotely in an unmanned fashion monitoring a particular region. So sensor networks become handy. So sensor networks can be classified broadly into two types. One is the stationary sensor networks. So this is what most of the literature talks about. In the sensor network community, people talk about mostly stationary sensor networks. This is the classical form of sensor networks. Stationary sensor network means that all the nodes in the network, in the sensor network, are stationary. They do not move. Any of the nodes, none of the nodes in the network moves. Whereas in a mobile sensor network, it is essential that some, or in the extreme case, all the nodes in the network would move. So that is the main distinction between a stationary sensor network and a mobile sensor network. There are multiple applications of mobile sensor networks. Mobile sensor networks are found in oceans. So basically, you know, when when we try to deploy sensor nodes on a ocean, the nodes will be mobile due to the fact that there are ocean waves and currents. So such a network is going to be a mobile sensor network. Not only oceans, in the terrestrial environments also, sensors fitted to the different trucks and buses and cycles and so on, which basically move on the road. These, because of the mobility of these vehicles, the nodes they move, and that is why we have a mobile sensor network. That is how we have a mobile sensor network. Similarly, nowadays people are talking about aerial sensor networks, and that is what we have covered in the UAV. So when we talked about UAV networks in the lecture on UAV networks, essentially if these UAVs are fitted with different sensors, then what we have are aerial sensor networks or UAV based sensor networks. So these are the main two classifications between the stationary sensor networks and mobile sensor networks. So a typical sensor node is sort of like a mini computing device, which has some additional capabilities of sensing. A typical sensor node has a sensing unit because it is a sensor node, it has a sensing unit, it has a component which is a sensor which can sense certain physical phenomena according to the way they have been designed. Processing unit means a processor. So we have the sensing unit, we have a processing unit, then there is the transceiver unit for communication purposes, a power unit for powering up the node. So, typically different types of batteries are used, typically lithium ion batteries are used. Then there are other application dependent units that can also be there in addition to these core units. So, as we can see that whatever you find in a mini computer, a computer is nothing but where there is processing capability. So, a processor is there in a computer and here as well, right. So, in a sensor node as well, plus communication capabilities are there, plus energy to power all of these things, the sensor nodes holistically, right. So, this is the typical architecture of a sensor node. So, here are some pictures that have been taken from different sources depicting the sensor nodes. The sensor nodes are originally envisioned to be very small in size and they come in diverse shapes. So, this we can, by looking at these figures, we can see that the sensor nodes are typically comparable to the size of a fingertip, to the size of coins, or they are much smaller compared to the size of a palm human palm, human hand. And this is with reference to a ballpoint pen. So, a tip of the ballpoint pen. So, you can, from these references you can understand how small these sensor nodes are. Now, that is regarding the size. Regarding the shape, the sensor nodes come in different shapes. They could be circular, spherical, they could come in different other shapes, rectangular, square, and so on. The sensor nodes, they are multifunctional. So, depending on the type of sensor that is installed, that is embedded in these nodes, they can sense different things. They have very short transmission ranges. They have very short transmission ranges because of the, again, the limitation of the transceiver unit, because of the size of the nodes, again the capabilities of each of these components are also very limited. So, these sensor nodes, like a computer, they have an operating system. TinyOS is a very popular operating system that is used in the sensor nodes, and the sensor nodes are, because they are very they are battery operated, they are battery powered, they have a very limited lifetime. And not only that they are battery powered, but the batteries that are used in these very small sized sensor nodes, you can imagine that the batteries are also very small in size, much smaller in size compared to these small sized sensor nodes. So, consequently, due to the electrochemical efficiency of a battery also depends on the size of the battery. So, consequently, the batteries also have very limited lifetime. They have very limited lifetime, and because they have very limited lifetime, what is very important is to ensure that whatever solution, hardware, software, or whatever it is that is designed specifically for sensor networks, the solutions should be very much energy efficient. They should be very much energy efficient. So, the algorithms that you design, the protocols that you design, the hardware that you design should be designed in such a way that energy consumption is very limited. The sensor nodes are very small in size, typically less than a cubic centimeter. They must consume extremely low power. These are the things that we have already seen. And what makes sensor networks interesting is that these nodes, the sensor nodes in the networks, operate in an unattended manner. They are designed to operate in an unattended manner in a highly dense area. They should have very low production cost and they should be dispensable. This is one of the visions of these sensor networks. So, basically to have very low cost sensor nodes, the nodes which can be the nodes which can have low production cost, which can be fabricated at very low cost, and this should be so much low cost that if a particular node runs out of its battery, or if a node is damaged for one reason or another, then once you have deployed these nodes, you forget about them. So, they should be dispensable, and the way these networks are supposed to operate and the individual nodes in them is that they should be autonomous. There should not be any human intervention, human beings coming and doing things for these nodes. That should not happen. They should be able to run on their own, and they should be adaptive to the environment in which they operate. So, if there is any change in the environment, the node should be able to strategize itself accordingly. There are different applications of sensor networks. Here are a few examples. I have already named few examples at the beginning of this lecture. So, measurement of temperature, measurement of humidity level, lighting condition, air pressure, soil makeup, noise level, vibration, and so on and so forth. These are not the only few applications to name. So, sensor networks can be used for agriculture, sensor networks can be used for healthcare, and so on. So, here actually on the right hand side, what we see are some healthcare applications of sensor nodes, sensor networks. So, and later on in another lecture, we will talk about how sensor networks can be used for healthcare, where on a human body the sensor nodes can be deployed, and these sensor nodes will be sensing different physiological functions, and they are going to send the sensed information to the base station for further analysis. So, let us consider the figure in front of us. What we see over here is a source node, and there are a bunch of other different sensor nodes. The source node as well as the sink node, the yellow colored sink node, these are also sensor nodes like the other gray colored nodes, but additionally the source node is the one, source node is defined to be the sensor node which basically senses a particular object or senses something. So, and the sensor node is going to sense, and through a multi-hop path the sensed information is sent to the sink node. Now, as you can see that the arrows over here are shown in the reverse direction. So, I already told you that the sensed information flows from the source to the sink. On the contrary, I have shown you in this figure that the links, the arrows are in the opposite direction. So, this might occur to your mind that why is it shown in the opposite direction. So, the reason it is shown in the opposite direction is that these arrows basically the communication between the sensor nodes in a sensor network can occur in two directions, one from the sensor node towards the sink, the other one from the sink towards the sensor nodes. So, what is shown over here is from the sink towards the sensor nodes, towards the source sensor node and the other sensor nodes. So, this basically represents the sending of a query. So, for instance, more specifically, if I have to clarify this thing, we have node number 14 which sends a query, a broadcast query maybe, to all the other nodes in the network, saying that does any of the other sensor nodes see any human activity occurring around them. So, node 17, who in fact sees a human object, responds back by saying that it does. So, what is shown over here in this case is the direction of transmission or propagation of the query. Now, let us complicate our scenario little further. So, in the earlier case we had a single object and a single source detecting a single object. Now, let us say that in addition to the human being, like in the previous diagram, we have two other different types of objects. We have a vehicle, and we have a box, let us say. So, now in this particular case, a box or a building or whatever it is, so 3 different types of objects. So, now we have a single source detecting multiple objects. Now we have the scenario of multiple sources detecting a single object. So, we have nodes 1, 2, 4, 15 and 17, these blue colored nodes, which have all together sensed the presence of a vehicle. Another example of multiple sources detecting multiple objects. So, here you see that earlier also we had the case of multiple sources detecting, but it was a single object which was detected together by them. But here we have multiple sources and multiple objects together. So, multiple sources detect multiple objects. So, this is what is depicted over here. So, like in the previous case of multiple sources detecting multiple objects, we can also have another situation, another scenario of multiple sources detecting multiple objects. So, like unlike in the previous case where all the sources as well as the objects were co-located, over here we do not have the sources and the objects, the different sources and the objects co-located. So, but still this is also a case of multiple sources detecting multiple objects. So, we have these different sources, source node 1 detecting the vehicle, source node 2 detecting a building, and source node 6 which is detecting a human. So, we have these 3 different sources which are not co-located, which are far apart from each other, and they detect 3 different objects. Now, let us look at some of the common challenges, behind implementing sensor networks. The sensor networks that are to be designed and implemented, they suffer from some of the very prominent challenges with respect to scalability. For instance, scalability means that if you are increasing the number of nodes in the network, how does the throughput perform? So, it has been typically shown that in a network, if n represents the number of nodes in the network, then the throughput decreases at the rate of 1 over square root of n. So, this is a very serious thing, because from 2 nodes to 4 nodes, for instance, if you increase n, then the throughput basically goes down quite drastically. But at the same time, we need to have large number of nodes to be deployed in a sensor network. So, how do we handle this? Quality of service. Quality of service basically concerns offering guarantees in terms of bandwidth, delay, jitter, packet loss probability. These are some of the measures of quality of service. So, these are also known as quality of service parameters in networking. So, these quality of service parameters, offering guarantees in terms of them, for example, offering guarantees in terms of the bandwidth, offering guarantees in terms of the delay, etc. These are important requirements of any network that is designed and deployed. Now, the main problem with these with offering quality of service guarantees in these networks is that these networks have very limited bandwidth, and there is unpredictable changes in the RF channel characteristics in these networks, in most of the cases due to the fact that these networks, the nodes in these networks, are deployed in environments which are quite chaotic in nature, and due to such a reason, these networks, the nodes, the environments in which they operate, they have very chaotic channel characteristics as well. Energy is something that I have already told you. These nodes are have very limited battery power. The batteries in them are very small in size. So, the nodes need to cooperate with one another, with the other nodes, for relaying their information. So, these nodes not only have to perform their own regular tasks, but they also have to cooperate with the other nodes for relaying the other nodes information. So, consequently, energy is a very crucial concern in these networks. These networks have an open medium like other wireless networks, and they are prone to different types of attacks. So, malicious attacks, infiltration, eavesdropping, interference, and so on and so forth, which make these networks very much vulnerable to these types of attacks, and security consequently is a very important issue in these networks. So, now let me show you few different types of different flavors of sensor network. One of the very prominent deployments of sensor networks is called the prominent architectures of sensor networks is called the sensor web. In a sensor web, as we can see over here, that we have different sensor networks, we have different other things, we have researchers, we have historical data, we have weather forecast, tsunami, we have pollution detection, etc. So, all these different data are basically sent to the web and probably to a computer grid where the data can be processed further. Data acquisition. So, in these networks there are two phases. The first phase is real time or non real time data acquisition, and the other thing is after the data is acquired, sending the data, sharing the data with others. So, data dissemination. So, these are the two important steps or two important parts of these networks, the sensor web networks. So, for enabling sensor webs, there are different things that are used. One is there are different components of these sensor webs. So, all of these are different components. So, I am not going to read through all of them, but as you can see over here, sensor modeling language. Sensor modeling language is a language that is used to model these sensor webs, right. So, similarly, you have the transducer modeling language, transducer ML, you have the sensor observation service, sensor planning service, sensor alert service, and so on. So, like this, a bunch of different services, modeling languages, and observations and management. These are the different components of sensor web. These sensor networks, like the ad hoc networks, have specific requirements in terms of cooperation by the intermediate nodes with cooperation of the intermediate nodes with the source and the destination nodes. The reason is that these are also multi-hop networks. Like the ad hoc networks, the sensor networks are also multi-hop networks, and because of that, the intermediate nodes, they would have to cooperate. But at the same time, these intermediate nodes are very much energy constrained. So, these nodes have a tendency not to cooperate. So, there are two extremities. One is that we can have a case of total non cooperation, or we can have the other extremity of total cooperation. So, in the case of total non cooperation, none of the relay requests that a particular node receives is forwarded further, and so in the case of total cooperation, all the relay requests that a particular node receives will be forwarded further. So, neither total non cooperation nor total cooperation are ideal because of obvious reasons. So, there are when we talk about cooperation, issues of selfishness, self interests, symbiotic dependence, etc. become very important. There are security challenges in cooperation as well. So, we have, as we have seen, that we have a resource constraint, wireless, open environment. So, where there is no centralized network management or certification authority, and there is existence of malicious nodes. These nodes are prone to attacks, infiltration, eavesdropping, and interference. They can be captured, they can be compromised, false routing information can be sent, and so on and so forth, all of which together can paralyze the whole network. The cooperating node or the node being cooperated consequently might be victimized. So, cooperation in such a scenario is not a very ideal thing. So, but at the same time, cooperation has to happen, but being cooperative will make these nodes or the networks vulnerable to different attacks. So, depending on the type of node behavior, the nodes in these networks can be classified into two types: normal and misbehaving. So then within the misbehaving nodes, so there are different types of misbehaving nodes. Normal nodes are the nodes which behave normally the way they are supposed to behave. Misbehaving nodes are the nodes which misbehave, which do not follow the protocols that they are supposed to follow. So they can further be classified as unintentional misbehaviors or intentional misbehaviors. Under the unintentional category, we have the failed nodes and the badly failed nodes. In the intentional category, we have the selfish nodes and the malicious nodes. So failed nodes are basically those which are unable to perform an operation. So and these operations are the ones which they are supposed to perform. They are supposed to perform, for example, certain, they are, let us say that they are supposed to do some computations. So they are not able to do that, maybe because the node has run out of its battery. So or maybe there are some environmental issues due to which the node has failed to operate. Badly failed nodes are the ones which have not only the which exhibit not only the properties of a failed node, but also additionally they can send false routing messages which are a threat to the integrity of the network. Selfish nodes are typified by their unwillingness to cooperate as the protocol requires whenever there is a personal cost that is involved. So for example, a node might behave as selfish, and instead of forwarding the packet that it receives, it might drop the packet. Malicious nodes basically on the contrary, so they are not like the selfish nodes. So in the case of the malicious nodes, they deliberately disrupt the correct operation of the routing protocol, denying the network service if possible. There is another type of node which is called the dumb node, which basically has been proposed. This kind of dumb behavior has been observed, and they have been proposed by the researchers in the SWAN group, IIT Kharagpur. So in dumb behavior, what happens is basically, so what happens is you have the sensor nodes which are deployed in an open region, and in these nodes they can get affected due to high temperature, rainfall, fog, and other adverse environmental conditions. So because of that, what happens, the communication range, because of these environmental adverse conditions, the communication range basically shrinks, and because the communication range shrinks, the sensor unit on the other hand can sense the way it is supposed to sense. So these nodes, they can sense, but they are not able to transmit the sensed data forward. So with the resumption of the forwarded of the favorable environmental conditions, the dumb nodes work temporally. So dumb behavior is temporal in nature. So what it means is that at certain point in time, the node may be able to behave the way it is supposed to behave, but at a later point of time, at another point of time, maybe due to the occurrence of heavy rainfall, or maybe due to heavy fog and so on, the node is able to sense the way it is supposed to sense, but it is not able to communicate with the other nodes. So whatever it has sensed, it is not able to send it further, send it forward. So the node either has to buffer, and then if the buffer is full, the packet gets dropped. So different issues become very important when we are thinking about dumb nodes. So first of all, one has to detect the presence of a dumb node, detect the presence of or occurrence of dumb behavior among any of the nodes in the network, and then after that the nodes have to be identified, and they have to and connectivity has to be re-established around those dumb nodes by maybe isolating them and so on. So around these dumb nodes, the connectivity re-establishment is the next important thing that should be done. So there are different schemes that have been proposed. CORD and CORAD are two popular schemes that have been proposed to re-establish connectivity between dumb nodes and other nodes. So few other things are very important in the context of sensor networks. We will cover topology management in a later lecture, and so in topology management there are different issues. So in our group we have worked on event aware topology management. So depending on the location of an event, depending on the area, the span of the event and the duration over which the event is occurring, the topology management can become important. So, topology management means that first of all the topology has to be discovered, and thereafter the topology has to be tracked and it has to be managed. So, this is important. So, this will cover later, and the next thing is the self management of wireless sensor networks. The wireless sensor networks, as we have already seen, they are supposed to self organize themselves, they are supposed to self manage themselves, and that is quite obvious, and this comes with lots of benefits. But at the same time, so what happens is these sensor networks, so this kind of self management comes out to be challenging. So, the reason is that there is lot of, so one of the things actually, one of the things that we have done is that we try to identify that how we can make this thing efficient, how we can make the self management efficient. So, for this actually we have proposed a particular framework called the INSEM framework, where we try to identify whether this currently sensed data is more informative compared to the data that was earlier received. So, if it is more informative, are there more neighbors, this is are the neighbors more informative, and so on. And if it is not, so if the currently sensed data is not more informative, then are the neighbors more informative, and so on. So, like this, so this is the decision tree, the decision framework about how to execute this particular self management scheme. So, with this we come to an end. This is the list of references. Like before, we have listed all the different papers and books that can be consulted for understanding the basics of sensor networks. Not only the basics, actually all of the different aspects of sensor networks that we will also be covering in the later course. So, these books will come out to very handy. So, let me just give you few highlights. This paper basically talks about self organizing sensor networks in the presence of dumb nodes, and so similarly this paper also does the same. And then the sensor web material on sensor web is available in this particular paper, and so on. So, there are two books that I should mention. One book is these are the two books that actually have been published by me on sensor networks. So, one book is a very recent book by Obaidat, myself, and this book is titled Principles of Wireless Sensor Networks. It was published in 2015 in by Cambridge University Press. So, this book is very important, and the other book is Guide to Wireless Sensor Networks, published by Springer, and so these two books are very much useful resources for understanding sensor networks, the basics of sensor networks, plus also the advanced topics in sensor networks. Thank you.